In the previous videos, we looked at what is encoding, encryption, and hashing, and how Spring Security can leverage them using password encoder. So I have been saying that password encoder is the responsible inside Spring Security which handles validating the password by leveraging the hashing, encryption, or encoding, whatever you say to it. But let's try to look into it what exactly present inside password encoder definition. So when I say password encoder, it is an interface available inside Spring Security and it has primarily three methods. One is the very first one, which we call it as encode, which accept the raw password from the user. Though we have using the word encode, that doesn't mean this applicable only for encoding but not for encryption and hashing. So here it took as a general term, encoding means converting from one form to another form, either by using encoding algorithms or encryption or hashing algorithms. So the purpose of this method is whoever implementing this method, they should accept the raw password which is coming from the framework and they have to encode it as per our the requirements. Suppose think like I used to use some hashing algorithm to use inside my application so that no one can reverse it or decode it to see the original text. So this method will be called by Spring Security Framework as soon as it receives a credentials from the user and it will try to generate a hash out of it based by taking the original text. So once we have that hashed password, then Spring Security leverages matches method. So matches method is the place where our Spring Security first try to call our encode method by passing the raw password and in return it will get the hash value of the text that we received from the user and at the same time it also accepts another parameter which is encoded password which we already saved inside the database. So it will take both the hash values and try to compare. If it matches, it will return a boolean true, otherwise false. So based upon this method, framework will decide whether I should authenticate the person or not. And at last, we also have one implementation method, which is upgrade encoding. So by default, this return false. The purpose of this method is, suppose you want to make your hashing algorithm or encoding or encryption algorithm to make it even more complex for the users to decode it. So that's where you will mention upgrade encoding as true, which means Spring Security will try to do encoding on top of existing encoding. That means you will be doing that encoding or encryption or hashing two times, which gives you more security. But that doesn't mean you should always use this method by overriding it to true because sometimes trying to encoding the same string multiple times will slow down your process because hashing, encryption, they all took some good amount of time and processing time. So that's where if you try to make it even more complex, so then you should be in a position where you don't have any issues that taking more time compared to what you initially have for a single encoding. So this is a sample interface provided by Spring Security. And at the same time, Spring Security also provides different flavors of password encoders that we can leverage inside our application based upon our requirements. You're always free to go and implement this password encoder and you can build your own logic inside this encode matches method as per your algorithms, as per your application requirements. But to help you to get started, we have five different of password encoders provided by Spring Security, which is no op password encoder, which we already using previously. And next is standard password encoder, followed by PBKDF2 password encoder, bcrypt password encoder, and scrypt password encoder. I would say most of the application, they should be good if they can leverage this existing password encoders that Spring Security provides. The reason is they are already following enough algorithms and security measures that no one can decode your password. And you can say most of our industry applications, they are using bcrypt password encoder, which is the famous one in the industry. That's where we'll do some hands-on with the bcrypt password encoder in the coming videos also. So now we have basic understanding of what is password encoder. Let's try to deep dive each of these password encoders and try to do some hands-on with the bcrypt password encoder in the coming videos. Thank you and bye.